How can we best teach our high school chemistry students about microtitration? 2 weeks ago, I explored with my chemistry students acids and bases, and I followed the following sequence instruction. First, I linked students' prior experiences to new ideas. Who doesn't know about stomach acid? I gave my students first-hand experiences with analyzing data, including conductivity and pH paper data. Third, I allowed them to use that data and evidence to form scientific claims. How do acids and bases compare to each other? What do they have in common? How are these aqueous solutions different? These very instructional sequences are suggested in this book by Patrick Brown. Check out my earlier video, linked above, where I go through the exact explore before explain activity. And the first question that students are trying to answer is, can you determine the key characteristics of acids and bases? But how can we extend the learning? So I just listened myself to this very podcast, Secondary Science Simplified with Rebecca Joyner. And episode number 7 that she released about a year ago revolves around how to make 1D lessons 3D lessons, following the next-gen science standards. Now, how does this apply to the acid and base lesson that I did with my students? Well, I made them 3-dimensional. So after the Explore Before Explain video, where my students delved into acids and bases on their own with my guidance, I did a molarity and dilution activity with them. Again, check my second video in the link above, where I share that exact activity following a cereal dilution and blue food dye. I like blue color. In that video, I emphasize why molarity, dilutions, concentrations are so key, because our blood, our urine, and tap water have some key components that we can analyze, and they all have different kinds of concentrations. This very activity, again, in the description below, has handouts with teacher keys all related to molarity. But in this final video, I really want to focus on titration, which is a lab neutralization. How can we make that logical step from exploring acids and bases, then coaxing them to mix the acid and bases, which in essence is a neutralization reaction, and then to delve deeper and figuring out how to determine the concentration of an unknown acid or base. Known acid, unknown in terms of concentration. So this image shows you how we did exactly that. We started off with a well plate, put it on a balance, tiered it, a set amount of hydrochloric acid, and then slowly added a little bit of sodium hydroxide, both solutions at 0.1 molar concentration. And at each increment, students measured the pH using pH paper. Why using a well plate? Well, you can do multiple trials. And these well plates came from Flint Scientific. And after you do it in one well, you can repeat the same activity again. And repetition is just so key for student learning. Zoomed here is a picture of the specific pieces of pH paper that one student used for this activity. As you can see, the first paper on the left looks very reddish because we started with an acid. And as more and more base is added in about 0.5 gram increments, they see that all of a sudden that pH is going to jump up until it reaches about 11, 12 or so in terms of pH. So sure, if you overshoot the amount of base you add to acid, you go beyond the neutralization and you get to the basic range. And my students also did the opposite, where they started off with a base and then they added the acid and they saw the flip. So I had them write a claim evidence reasoning statement based on the central question, what happens when you mix an acid and a base, either adding the base to the acid or adding the acid to the base in the well plate on top of a balance. This shows you the actual key, again with the pieces of pH paper, and then using Google Sheets to graph the actual pH paper data. So very basic, rudimentary values, not as precise as perhaps a digital pH meter, but it gets the idea across. And you see here that very distinctive sigmoid curve. Again, if you flip it and you start with the base and you add the acid to it, that will also cause the sigmoid curve to flip. So they've explored acids and bases. They've further explored combining acids and bases. They've seen the trend in a graph form. Now let's extend it to help them figure out, can you actually determine the concentration of an acid or a base through experimentation? So this kind of helps them into setting them up for a simple titration reaction. So in their bin is still that distinctive well plate, but now instead of pH paper, they see in their bin a little dropper bottle that contains the acid-base indicator, phenolphthalein. How should we use that? So you're seeing here my student tare the balance. They already did a titration in one of the wells, and they're now doing it in a second well. They're starting off with the acid in the well. They now add little increments of base, and because phenolphthalein is in there, they notice, what the heck? There's that little bit of distinctive pink color, but if we swirl the plate, well, then we're actually going to get rid of that color. And so they understand that they now need to be much more precise, because we want to figure out how much base does it take for that acid, for that solution that started off acidic, to remain just barely pink. So that will help them determine the concentration of the original acid. We're getting closer, reaching that step where we've added that last drop where it's going to stay that light pink color. If the pink is too dark, that tells them really that they've overshot it. So it's key that they just barely get it to that light pink, and that means their percent error will probably be lower than if they overshoot it. There it is. That's probably the last drop needed. A little swirling, it stays pink. We've reached the end point of the titration. But let's not forget that a microtitration is different from the real setup. So they do get to see the real setup in the classroom, but because I don't like to waste a lot of material, I actually only have them do the microtitration, and they basically take a look at the burette with the stopcock and the flask, and they label the diagram, and they use the internet to figure out what is the difference between an analyte and a titrant, and what is the endpoint of the titration, to help them understand the different components of a real titration setup. So with that microtitration in mind, it's so easy to do multiple trials. One trial using 0.1 molar, a second trial using 0.2 molar hydrochloric acid, and then the third trial, I give them a different acid, namely sulfuric acid, again at 0.1 molar, and then the light bulb starts to go off. So for every 1 molecule of H2SO4, 2 hydrogen ions or hydronium ions are released. What's going on here? So they're then starting to understand the difference between a monoprotic acid, like hydrochloric acid, and a diprotic acid, like sulfuric acid. To be honest, we did not get to this third extension, so obviously you can do a titration not starting with an acid, but instead starting with an unknown base, and then using the acid as your titrant, the base as your analyte. The same concept would work. We can then take it all the way back to the beginning of acids and bases, where they started to explore with that bin containing a weak acid and a weak base, possibly vinegar and baking soda, and coming up with commonalities. And now they've learned so much more, so they can expand on their Venn diagram with the list of the things that they've learned. So here you're seeing the actual comprehensive list that I would like my students to come up with. Acids A, H plus away, base B burglar. What are their differences? What do they have in common? These slides can be found in the link in the description below. Here are the standards, Next Gen Science Standards and the New York State Science Learning Standards, HSPS 1-5, focusing on collision theory and rates of reactions when it comes to concentration. But what we're also really getting here with this lesson is HSPS 1-2, simple chemical reactions, HSPS 1-11, your New York State Science Learning Standards, that focuses directly on acids and bases. So I hope that this third video in the sequence of understanding acids and bases in terms of basic characteristics, in terms of molarity, and then figuring out unknown concentrations by doing a titration, in essence a neutralization reaction, will be helpful to your students. Again, check out the 3 videos that are part of this series and the lesson handouts in the description below. Thank you for watching, bedankt voor het kijken en tot ziens, see you in the next video.